Okay, this is activity 3. We're working through using a ratio table to find equivalent rates. In this scenario, we have a communication satellite that's in orbit and travels about 18 miles every 4 seconds. Identify the rate in this problem. So what are the two pieces? Remember, a rate is going to involve two different units. So the two different units we have are 18 miles and 4 seconds. So this every is like saying per second. So our rate that we have is 18 miles per 4 seconds. That could also be stated like this: 18, then I forgot my unit of M for miles, or MI, per 4 seconds. Now, usually unit rate is written in a reduced form. That is something that we'll kind of be working with throughout this section. But if we were going to reduce that down, that per is like a division bar. So if I were to take 18 and divide it by 4, it's going to give me 4.5. So if you had the reduced version, it could also be known as 4.5 miles per second, because that's reducing it down to miles and seconds when we divide those two out. So it says, recall that you can use ratio tables to find and organize equivalent ratios and rates. Complete the ratio table below. So the first scenario we have is our time is 4 seconds. Well, how far could we travel in miles in 4 seconds? That was stated right up here. We could travel 18 miles. So we've got 18 miles. Okay, so if we were going to travel for 8 seconds, well, that's just taking 4 times 2, right? So we're going to take our 18 times 2 to figure out what our new number there would be, and that would be 36 miles. Okay, so now if we were to look, well, 8 times 2 doesn't give us 12. So we can no longer use that times 2, but we can go through and use our unit rate that we had earlier when we broke it down per second if we wanted. So we could really reference back to this right here. So we could travel 4.5 miles in 1 second. Now we're going to travel for 12 seconds. So if I take 12 times 4.5, that's going to tell me how many miles I could travel. And when I do that, it gives me 54 miles. Oops. Okay, now I can continue using that times 4.5. So 16 times 4.5 gives me 72. And you can kind of see the pattern for every single jump. Because the time was changing by 4 seconds, we kept going up by 18. So that's something else you could use, is we're noticing we're increasing by 18, increasing by 18, increasing by 18. So we could continue that pattern, or we can continue to go through and do 16 times 4.5. And when I do that, oops, I already did 16 times 4.5. Sorry, 20 times 4.5 gives me 90. And had I taken 72 plus 18, it would also still give me 90 miles. Okay. How can you use a ratio table to find the speed of the satellite in miles per minute? Well, we kind of already did that when we went through and broke down up above in letter A. The other method we could do is we could take any of these out of the table. So I'm just going to prove to you, I'll take this last one. And we could set it up in the order that it was stated: miles per, which would be our slash mark, and minutes. So if I were to take my miles was 90 per 20 minutes. So if I take 90 divided by 20, it should give me that 4.5 that I went through and kind of found in letter A. And when I do that, it does give me 4.5 miles per second. Okay, the second part of this would be miles per hour. So if we could travel 4.5 miles in 1 second, well, we're going to have to figure out how many seconds are in an hour. So if we wanted to figure out how many seconds were in a minute, well, we would go times 60, right? Now there's 60 minutes in an hour, so we would have to go times 60 again. Okay, so we're going to take our 4.5 times 60, and that would give us 270 miles per minute, and then go times 60 again. which gives us, and that would be miles per hour. Wow, that's traveling super duper fast. You know, at first when we look at that and we say, oh, 18 miles per 4 seconds, that doesn't seem like it's that fast. But as soon as we break it down into miles per hour, it kind of helps us relate. We know how fast we tend to travel, like on a highway, 55 to 60 miles per hour. Okay. Here, 16,200 miles per hour. That satellite's traveling at a pretty fast pace. Letter D says, how far does the satellite travel in 1 second? Well, let's look back at our original rate that we had here. Right here. It could go 4.5 miles per second. So that's per 1 second. So how far does it travel in 1 second? 4.5 miles. Solve this problem by using the ratio table and by evaluating the quotient. Well, we've already done that previously, so we don't really need to go through and resolve it. It's just understanding what that rate really meant. Letter E says, how far does the satellite travel in half of a second? Okay, so within 1 second, it can travel 4.5 miles. How far could it go in a half of a second? Okay, we want to know in a half of a second. Well, we could either set it up as a rate, matching labels, and cross multiply divide, or we could just split that. Since we split the 1 second into half, or divided by 2, we could take 4.5 and divide it by 2. And when we do that, we get 2.25. And that would be miles it could travel in a half second. So to explain our steps, well, we could either divide by 2, or we could set it up as a proportion and cross multiply divide. Okay, so that's working with a real world scenario and some ratios.